one planned for this, and this was all spontaneous.
When they asked you to do something, you didn't say it was not possible. You had to find a solution.
Every day, every hour, literally, is something new and different. I've never been on anything like this.
There's almost nothing that's distinguishable. You don't see a piece of a desk, you don't see a chair.
I found a piece that was actually hit by the engine of the plane.
No one else in this world could put together what we put together here in such a short time.
The destruction of the World Trade Center on September 11th, 2001 was the worst act of terrorism in history. The devastation, absolute. The loss of life, appalling. If the sight of jet planes hitting those buildings and the fearful symmetry of their collapse wasn't shocking enough, the aftermath was unbelievable, unimaginable.
It was the largest structural failure ever. Where do you begin? But slowly, by the shovelful, by the truckload, by the barge load, an army of engineers, salvage experts, and construction workers got on with the job of cleaning up the site. This is their story.
When we got there at 2 o'clock, there were thousands. People were all over the place. You could barely see the smoke, the dust, the paper. It went for 10 blocks. So as you were approaching the scene, it was chaos with firemen and equipment and people just walking around with a dazed look.
Pretty bad, huh?
These pictures were taken by Brian Giancosa, a structural engineer and a member of the New Jersey Emergency Task Force.
It's going to Staten Island.
The magnitude, the size of the area that was collapsed was so large.
Thousands of people were buried in the rubble, and rescuers needed to know where to look.
You couldn't discern where Building 1 was or Building 2. And you have people searching that weren't familiar with the site. So we went up in a helicopter and took pictures so that we could overlay where the buildings were, provide them to the teams so that they knew where they were and where they were searching. We used that to plot the underground features, the path, the slurry wall, which is known as the bathtub, the city subway system, air shafts, parking garages, so that we knew what's underneath us.
The World Trade Center was more than just 2 towers in a 16-acre site. There were 5 other buildings and 11 acres of underground shopping, parking, and subway systems. It was incredibly dangerous work, but checking the damage in those underground areas was vital.
Loading docks. Loading docks? Yeah.
It's a real labyrinth of different conditions down there. You have areas that are intact, you have areas that are partially collapsed, you have areas that are fully collapsed.
While the debris continued to burn above them, engineers Peter Rinaldi and Richard Garlock were part of the first team to explore right underneath the collapsed towers.
This is a mess.
They took this video as they picked their way through the tunnel into the Path train station at the lowest level.
I'm just trying to get a good overall view of this.
We went in through what's called the north projection, which is a ventilation shaft with stairwells. We went down that stairwell into the actual Path tracks and started, walking along the tracks, doing damage assessment and trying to ascertain whether the wall was in good condition and whether the structure was still intact to brace it. And it was fairly well intact when we first got there.
This is platform B?
While we're underground, we find lots of remnants of life that was under there from before.
Even this floor is a little shaky.
Or you go by a newsstand and there's newsstand and it's almost completely covered in dust, so you can't necessarily read what's on the stand. You just see it's kind of an outline of the candy and the magazines and the papers just sitting there from that morning. When you walk in and you see those kinds of things on the desk and you can read, on top of the paper, September 11th, it just transports you back to that. It's a frozen state down there.
Above ground, the task ahead was staggering. Not only had the Twin Towers been destroyed, but surrounding buildings were on the verge of collapse. Richard Tomasetti is the president of the Thornton Tomasetti Group, the company that organized the engineering for the cleanup.
The buildings that are totally collapsed are Tower number 1, Tower number 2, the Marriott Hotel, and the World Trade Center number 7. And then the buildings that were partially collapsed are number 4, number 5, and number 6. But they had so much damage, the parts that are not collapsed will have to be demolished.
The top parts of the towers had fallen from 1,300 feet, hitting the ground at 220 miles per hour. Two 110-story buildings compressed into mounds of about 110 feet. Dan Hahn is an engineer who worked on the construction of the World Trade Center and is helping with the cleanup.
I estimate about half of the 110 stories ended up below the ground level, and the other half was the pile above the ground level.
There was enough concrete in the Twin Towers to build a path 5 feet wide from New York to Washington, D.C. The force of the collapse had pulverized it all to powder. Colonel John O'Dowd is the district chief of the Army Corps of Engineers, who were called in immediately.
The debris of what was the World Trade Center, there's almost nothing that's distinguishable. It was 210-story office buildings. You don't see a piece of a desk, you don't see a chair. On the first evening, when I actually went into Ground Zero, that struck you when you got up close to the site, that it was large structural steel and dust.
You stand in the middle of the area and everywhere you look, you see devastation. Quite frankly, when I first went down there, I kind of had this feeling that I had left my body and I was watching myself in a movie or a dream, wishing it would be over at any minute.
Ground Zero became a city within a city, with thousands of workers and volunteers. Within hours of the collapse, 700 Department of Sanitation workers descended on the site.
We were faced with rubble all over the street, burning vehicles, concrete dust all in the air, wires, electrical wires, gas lines, everything in the street. So you didn't know where you were walking, you didn't know what you were walking over. There were different kinds of belongings of people, in the street that we were worried about. Anything we were told that anything we find, we're supposed to call the police and let them pick it up. So it was a slow process, which we're not used to working that way.
Once the streets were cleared, the heavy equipment, more than 260 machines, could come in to remove what became known as the pile. The man in charge of the site is Ken Holden, the commissioner of the New York City Department of Design and Construction.
We've got a lot of very smart people working on what we consider to be an uncontrolled, demolition project. This was not a project that was planned for, and the success is in no small part due to the public agencies, a lot of public agencies, federal, state, and city, kind of letting down their bureaucratic barriers and regulations as we deal with this emergency, and a lot of the private companies putting away some of their normal competitiveness and succeeding tremendously, as I think we've done to date.
Now, the city pretty early on made the decision that the actual detailed crime scene investigation was going to take place on the other end when we got the debris to Staten Island, which eased the search rescue and the removal operations at Ground Zero, because a lot of the initial search rescue involved actually removing debris so that the urban search rescue folks could get into the areas.
Where's our bucket?
While the main task was searching for survivors, some workers were also looking for 4,000 pounds of heroin from the customs house and millions of dollars worth of gold and silver in the Bank of Nova Scotia vault. Both were eventually found. Peter Rinaldi is engineering projects manager with the Port Authority of New York and New Jersey, the agency that built the World Trade Center. Even for experienced engineers, every step of the cleanup is a riddle.
Yeah, this is a very unique situation in terms of the site. I mean, the challenges here, we're engineering it, we're using experience, so we've got a lot of experienced people here. And every day, every hour, literally, is something new and different. I've never been on anything like this. You're jumping from one issue to another, trying to solve it. You're trying to think, you're going on your experience, you're using your engineering judgment. It's really challenging.
When you begin to move things around on a pile like that, you need to be looking at it from an engineer. Now, when I move this piece, what other pieces are going to move?
When they asked you to do something, you didn't say it was not possible. You had to find the solution. An example, we put a 600-ton crane on a plaza that was designed just for pedestrian traffic. And we did it by inspecting the columns below, designing a steel grillage to span between those columns above the plaza. And within 24 to 72 hours, we had that crane in place in an area where cranes were not meant to go.
Ground Zero was smelly, dangerous, depressing, and still smoking for months.
It's smoking because there was a tremendous amount of heat generated by the fire, and there was a tremendous amount of steel there that was heated up. What you see there is as we uncover the steel and the air hits it, that steel is still hot. It's still at 600, 700, 800 degrees in parts of that site. So we're continually watering it down to suppress the dust as well as to cool it down. And then as we excavate it, we can take it off site.
The exhausting and endless effort continued around the clock, recovering bodies, removing debris, and excavating all the way down to bedrock.
No one else in this world could put together what we put together here in such a short time. And this is contractors that hate each other in the beginning. Everybody just coming here, unions, it all became a big family. I mean, there's the interior stuff, all the BS that goes on, I'm sure it's still going on. But we're all here, and we're all doing the job. And I think that says a lot about this country.
Brains and brawn together, clearing 3,000 tons of debris a day. What do you do with it? By September 14th, 9,000 tons of debris had already been removed from Ground Zero, 1,500 truckloads. About 1.5 million tons remained, the equivalent of 75,000 fully loaded trucks. Way too much for the crowded streets of Manhattan.
The city realized early on that with the amount of debris they had, taking it by trucks off of Lower Manhattan was going to tie things up forever. And if you ever wanted to get back to some semblance of normalcy here, you had to find a way to remove the debris that didn't close down all the arteries of the Staten Island Expressway, the Holland Tunnel, the Brooklyn Battery Tunnel, all the streets in Lower Manhattan.
The solution was to mobilize an armada of barges. George Whittock is vice president of Weeks Marine, one of the largest salvage companies in the world.
By about the second day, we had convinced the powers that be that, you know, the way to really move this material was via water. And we had commenced dredging operations at this facility and our other facility to get the required water depth. And so we were underway probably by the 13th fairly heavily, going 24/7, and have been continuing that schedule to today. This is Pier 25 on the Hudson River. It's one crane, the Weeks 500. We have another crane, 524, is a Model 28 Clyde gantry crane capable of lifting 155 tons. These cranes can handle both debris and structural steel. Each barge can hold between 50 and 150 truckloads, which makes the efficiency much greater. And it enables us to, the segregation can be done at ground zero, whereby debris that needs to go to fresh kills can be segregated from structural steel, which has a value. And so the operation's of a very large magnitude, but it seems to be running very efficiently.
As the cleanup gathered momentum, it caused a structural crisis at ground zero. The slurry wall, the dam that held back the Hudson River, started to weaken. If it collapsed, the whole site would be flooded. This industrial film on the building of the Trade Center describes how it was constructed.
A trench was dug down to bedrock, and a thick bentonite slurry was pumped in. The slurry was denser than the surrounding mud and dirt, and thus kept the trench walls from collapsing. As each section was completed, 25-ton cages of metal reinforcement rods were lowered into the slurry-filled trench. With the cage in place, concrete was poured in. In this way, an underground wall was built completely sealing the site. Excavation.
The slurry wall was part of the original construction of the World Trade Center, and it formed the perimeter wall for the whole basement complex, where all the equipment was for the chiller plant, the heating and cooling for the Trade Center, as well as all the parking levels, the storage levels, and even the mall, the shopping mall that was down a couple of levels. So this wall is important in that it creates the stability around the entire site.
The slurry wall was held up by the horizontal parking structures. Those were structural slabs that were holding up the sides of the slurry wall. When the towers came down and collapsed those horizontal structures, what was holding up the slurry wall and keeping the pressure from the mud and the water from the Hudson River is the debris. So as we take that debris out and take it down, we need to put in the tiebacks to support the slurry wall.
Only a few weeks into the cleanup, the urgency of that job became apparent.
One Sunday morning, as I walked the site early in the morning, one of the workers came up and said, "A crack just opened up." And I looked at it and I said, uh-oh. And what happened was a classic failure, shear failure of earth pressure. The wall actually moved. It started moving. On an emergency basis, we brought in over 50,000 yards of fill to buttress the wall. We put it in immediately. The wall moved about 8 inches to 9 inches total, but we actually slowed it down and then we actually stopped the movement.
The tiebacks were a permanent solution to the problem. On the surface, they look simple, metal plates and rods, but installing them was a long and complicated process.
We're drilling out through the wall on a 45-degree angle, 70 feet through the soil, and then another 35 feet into bedrock. When we get down to bedrock, we take these long steel tendons, we slip them down into the hole that we've cored, we grout them in with a strong cement, and then after that cement hardens, we actually stress them to 600,000 pounds to tie the wall back. And we're putting those approximately 10 foot on center all along the top of the wall, and then we're going to continue to go down for 4 more levels. We're now down almost to the 5th level of tiebacks on the slurry wall, and what we've been doing is tying it back, and we're finding as we go down that we've been able to stabilize it, and it's going much better than we originally thought. And the wall is really safe now and stable, and it's making the excavation and the recovery here on the site much easier and much quicker.
Planners originally estimated the cleanup would take over a year, but it's ahead of schedule by months. And as they dig deeper, they find more bodies.
You see a lot of construction equipment, and there's a temptation to consider this a construction site, but it's a lot more than a construction site.
What is it?
It's a graveyard.
At a place called Fresh Kills, the gruesome task of identifying remains. Framed by the fractured skyline of Lower Manhattan, a fleet of barges crisscrosses the New York harbor, from Manhattan to Staten Island with debris, and from Manhattan to New Jersey with structural steel. 8 to 10 barges every day, each one of them carrying up to 3,000 tons of what used to be the World Trade Center.
You look at each loaded scow with a reverence. You know there's remains in some form there, whether it be an ash or whatever. But it's not a routine job where you're moving a load of mud or rock. Yes, it's concrete and steel, but mixed in with that is people's lives or what was left of them.
The debris ends up on Staten Island, at a landfill site with the unfortunate name Fresh Kills, which comes from the Dutch word for stream. At 2,200 acres, it's the largest municipal landfill in the world, so huge you could see it from the moon. The site had been closed, but was reopened to deal with September 11th.
Once it arrives, it's unloaded by crane into a large containment area. From there, it goes by front-end loader into large dump trucks, and it's taken up to the sorting area. Once it's at the sorting area, the two processes happen. One is large grappling cranes remove the steel, which is searched by the NYPD. The remaining material, which is like a rubble, is either searched manually or put through screening machines.
The material, the smaller items that pass through initial separations on vibrating conveyor belts with police and FBI agents able to examine it and look for any evidence. If they spot something in the way of personal effects or evidence, they can stop the belt, examine it, remove it. That material then gets collected up again, spread on the ground, and the last step they go through is actually a hand kind of raking through the material. They're examining the debris. They are in fact recovering remains still, personal effects, also evidence that you might find from aircraft black boxes, aircraft parts, things like that.
It is absolutely horrible work. Thousands and thousands of items. Things so small you can't imagine them surviving the fire or the crush, let alone being found.
They actually found my ID from the World Trade Center from the 72nd floor where my office was, and they just got it to me today. This is a World Trade Center ID that I had at my desk, actually. This is something that had my name on it, so they were actually able to identify Peter Rinaldi, Port Authority of New York and New Jersey, and able to get it back to me.
You know, I drive by the wrecked vehicles, and one section of where the vehicles are is mostly emergency vehicles, police and fire trucks. I remember seeing those at Ground Zero on September 11th, and in subsequent days after that until they removed them, and they're all out at Staten Island now. You can't help but when you drive through there, it just brings back kind of the magnitude of everything that's happened.
I thought it was in the loop, the train, not in the station.
65 feet below street level, the last train to enter the World Trade Center on September 11th is still waiting for passengers who will never board. The path and New York subway tracks are at the lowest level of the World Trade Center. It took 4 months of digging to get to this point. As the piles here vanish, the piles of steel at Fresh Kills and the Hugo New steel recycling plant directly across the Hudson River in New Jersey grow larger.
We've pulled pieces out that basically defies what you thought was reasonable in terms of steel failure and, what could be done to a 3-inch piece of steel. Stuff is broken, stuff is twisted into like a DNA helix, or a piece of licorice.
Hugo New Schnitzer is one of the biggest recyclers in the U.S. and is buying the World Trade Center steel, more than 300,000 tons of it. So much steel, the market is flooded and the global price has dropped. Bob Kellman is the man in charge of the operation.
Typically, there'll be between 400 and 500 tons of structural beams in each barge. It'll take us about 12 hours to unload those beams. We'll prep some of the heaviest beams right here alongside the dock face because it's just easier to do it here. If it's over 1.5 inches thick, we are going to have to lay it out in what we call a burning bed, and we'll put men on it with oxyacetylene torches, oxygen and acetylene. You've got to burn it very hot, melting temperature in about 2,000 degrees. And once the men get started, they can cut in the range of 1.5 tons to 2 tons an hour. Typically, we try and cut them into 1-ton pieces, 2,000 pounds per piece. The steel mills that we're selling the scrap to need to melt this down in a pretty efficient manner. So far, we've shipped some material to Turkey, South Korea, China, mainland China, Malaysia. It's going to be made into hot-rolled bands, cold-rolled bands, flat bars, reinforcing rod, any variety of basic steel products.
Eventually, this site will be empty, the steel all recycled, the debris buried at Fresh Kills. It has been an extraordinary achievement of engineering, technology, problem solving, and sweat. But what do we learn from all those pieces of twisted steel?
One of the most dramatic events in New York City in the 1960s was the construction of the World Trade Center.
The World Trade Center was so big it had its own zip code. The towers were built by the Port Authority of New York and New Jersey to revitalize Lower Manhattan and were not instantly loved by New Yorkers, but they became the most important part of the city's skyline and a potent symbol. The towers were the tallest buildings in the world when they were completed in 1970 and 1972 at a cost of $1.1 billion. They were designed by Minoru Yamasaki, a man who was afraid of heights and insisted on placing the hollow steel tubing on the exterior of the building at intervals of 3 feet so that people wouldn't be nervous looking out the windows. He wrote that the Trade Center was a living symbol of man's dedication to world peace. But it was built for business. The man whose company constructed the towers is John Tishman.
In the first place, it had very high-strength steel on the lower levels, what I refer to as the harps, were very complicated. And the whole structural system of the exterior was unusual in that it was all made up of welded plates. The floor system were prefabricated, trussed, major sort of platforms that were laid from one with large, long spans. And so it was different.
Richard Zatola is a partner in Leslie E. Robertson Associates, the company that designed the structure of the World Trade Center.
The core was what we call a gravity load resisting system. The exterior wall also resisted the self-weight of the building, carried it down to the ground.
The strength of the buildings came from steel. There were 47 steel columns in the core that supported about 60% of the weight. The other 40% was supported by the exterior columns that also helped the buildings withstand high winds.
So in terms of the wind load, if you want to talk about wind load, the exterior wall of the building was a tube system, a structural tube system, and it gave it the lateral stiffness and strength to resist hurricane wind forces, which were the design wind forces for the towers.
The buildings were attacked by terrorists in 1993. The car bomb killed 6 people and injured more than 1,000. The repairs, which cost $300 million, included improved security, lighting, and stairwells. But there was very little structural damage, and no one could foresee any need for additional barriers to terrorism.
It was designed to be invincible for all the natural forces of wind, earthquake, and the regular expected weights. It also contemplated the possibility of being hit by a major airplane. What was never contemplated was the size, I think, of the fuel load that these planes were carrying.
No one had ever contemplated what would happen on September 11th. At 8:45, American Airlines Flight 11 roared into Tower 1. At 9:05, another Boeing 767 hit Tower 2. The 2 aircraft carried more than 20,000 gallons of jet fuel. And as it burned, it softened the steel like spaghetti in boiling water. What happened on the outside, we all saw. What exactly happened inside those buildings may never be completely known, although it remains a subject of much educated analysis and controversy.
In Tower 1, the plane hit the building at an angle to where, when it went inside the building, it hit the core on the long side. When it hit Tower 2, the core is rotated, so it hit the core on the short side. So that's why a lot of the plane actually came out the building to the east and also on the north side, and there's lots of fragments that came out of the building because there was not much in between one face of the building and the opposite face of the building because of the core being turned. That's the general difference between the 2 buildings.
The sequence of events as we understand it now is that first the plane hit and there was not much of a strength in the building to keep it from going in. So it went in and dropped the fuel and caught fire. So the fire was going on for almost 1 hour and sometimes more for the second tower. And what happened during that period, the floor steel that was on the floors kind of got soft and the floors collapsed.
And the floors are needed to brace the exterior wall, the columns of the exterior wall as well as the interior wall. I mean, elements that work in compression need bracing in order to maintain their strength. As you remove bracing, you decrease the capacity of that column. If you increase the length of a column by a factor of 2, you decrease its capacity by a factor of 4.
And at the same time almost, the columns, vertical elements, got also soft and they buckled and the top portion of building that was sitting on those columns dropped on the lower portion, and the whole thing went down. So it was like dropping a 20-story building on top of a 90-story building.
The word autopsy is not usually associated with a building collapse, but an autopsy is what it is, perhaps the biggest ever. Iranian-born structural engineer Hassan Astaneh is one of the experts studying the disaster. As he combs through the twisted steel at the Hugo New recycling plant looking for clues and evidence for the National Science Foundation, he writes his name on every piece he wants saved.
Everything here is bent and mangled, but it's important to find out the pieces that actually buckled when they were standing, because everything fell down and bent. That's not important. What's important is to find the pieces that were up there, buckled, and started the collapse. This is one of them.
Each exterior column was marked during construction. And incredibly, out of the hundreds and thousands of pieces, he believes he has found one of the points of impact.
This piece is very important because this is the place where either engine or other part of plane hit the building and went in. This is exactly that area. This is the inside of the building and the bottom is outside. So something very heavy came here. You can see the curve. Something came here and hit this and bent the whole thing in and went inside the building.
Dr. Astaneh also found one of the core columns, which could be a vital clue to the fate of the towers.
I found a piece that was actually hit by the engine of the plane. So the engine went in and hit this piece of steel inside. That was very exciting because so far we did not have any evidence of what happened inside the building. This column was hit by the engine of the plane. And the engine took a piece of this column out, like a bite. But the column was standing and still holding the load. Later, of course, due to fire, everything collapsed. This connection is the floor connection. You can see the floor was here, and as the floor collapsed, the support bent downward. What this tells us is that first the floors collapsed, then the columns buckled. So that sequence is very important. Which one failed first, floors or columns? And this tells us that the floors first went and then the columns buckled.
Tower 2, the second one hit, collapsed in just 54 minutes. Tower 1 fell 29 minutes later. Both towers were gone in 1 hour and 43 minutes. An hour less than it took the Titanic to sink. Why did Tower 2 fall first?
There are a couple of theories on that. One is the fact that Tower 2 was hit approximately 25 to 30 floors below the top. Tower 1 was hit approximately 12 to 15 floors from the top. So Tower 2 had more weight above the damaged area.
Tower 2, the core was in the north-south direction. So you had about 60 feet of clear space in the east-west direction on either side of the core. And when that aircraft came in, it sliced along that 60-foot corridor, and it also took some interior columns, in my opinion, along the long length of the core columns.
So it's possible that in Tower 2, in addition to the damage on the facade, the outside columns being destroyed, there were more columns destroyed on the inside. Whereas on Tower 1, It was an orthogonal hit, straight on. And whatever part of the plane went through was hitting the long face of the core on the inside, and probably did not take out as many columns or as significant columns on the inside as happened with Tower 2.
My own feeling is that the first tower that was hit, the plane went in and did not explode. So the fuel was burning very gradually because there were not much of windows broken, there was not a wall exploded out. So the oxygen input was very limited. The fuel did not have enough oxygen. But the second tower, when it was hit, the plane exploded inside and threw out a lot of walls and opened up the oxygen flow. So the oxygen was able to get in and burn much more intensely than the first tower. So the first tower lasted 1.5 hours, but the second tower has lasted only 1 hour.
Given the heat of the burning jet fuel inside the buildings, should anyone be surprised they fell?
I didn't know the buildings would fall. I worked for the Port Authority for over 30 years. I worked on the design of the foundations for the World Trade Center. I knew the structure. It surprised me as much as a number of the other designers that worked on the building.
I was amazed. I was absolutely astonished that not only that they fell, but they fell in that manner.
So was the collapse inevitable?
I don't think any building could have withstood the fire. The question is how much damage would have been done to the building and whether it would have stayed up at all. That's real pure speculation on somebody guessing whether other building would come down or not.
What's interesting is the fireproofing on this steel. The structure had about 1.5-inch thick fireproofing material that was placed on the steel structure. This is the inside of the building, and inside had that fireproofing. Now what you can see here is, if you look carefully, there is a very thin layer of residue here. This is actually that fireproofing. The heat was so intense that fireproofing burned and melted and ended up being a sheet of very glass-like looking material that no longer could protect the steel.
Was there more steel in that building than most? I mean, the core or whatever. Would it have been safer if it had been more concrete?
I don't think anything could withstand the force and effect of the oil explosion. It would be almost impossible to have more concrete. First place, you'd have added weight, and secondly, the concrete columns, if you use them substantially where they carried weight, they would have been too big to accommodate people. I mean, there'd be massive columns to hold 110 stories.
Long after the last truckload has been hauled away, there will be unanswered questions about the massive failure of concrete and steel. But among the more immediate issues is the debate about what should rise in place of the towers, if anything should rise at all. After the fall, then what? The World Trade Center will be rebuilt. The question is, how? How many buildings? How high? And how will they commemorate the sacred ground? It's a political and ethical hot potato. One of the key players is Larry Silverstein, the developer who paid $3.2 billion for a 99-year lease on the buildings just 6 weeks before the attack.
Since I have the obligation to pay ground rent to the Port Authority, about $120 million a year, and since the lease obligates me to rebuild the World Trade Center, which it does.
The lease says that?
The lease says that. And since I expect to have $7 billion with which to rebuild
from
insurance company proceeds.
Frank Lombardi is the chief engineer for the Port Authority of New York and New Jersey, the agency that owns the land the Trade Center was built on.
There's several things that should be done with the site. The infrastructure is very important to rebuild because of mass transit, getting people there and having the intermodal facility. We have another opportunity to do what may not have been done, okay? The other thing is obviously to build the office space, the 10 million square feet. The retail is very important, and the last, that's most important, is to have all the stakeholders, including the families and friends, and have the victims' families involved in the memorial and what should be a suitable memorial for the site.
So the need to reinstate and improve transit will drive the early part of the rebuilding process. As to the rest, the Port Authority, the City and State of New York will also be involved in the decisions being made, as well as the people affected by the tragedy. Ray Gastel is on the Memorial Committee of New York New Visions.
There is a group of people that feel that the site as an entirety has to be recognized as a memorial. Now, and so some people feel that that means that literally the whole thing will be a garden, at least for a number of years, and it might transform. Some have suggested a sort of pattern of, the actual footprints of the two towers could become ponds, and then you could actually sort of reflecting ponds as sort of a major place of contemplation. There have been people who have suggested that the most important memorial was an incredibly high tower, which would give you a perspective out on the city. It wouldn't necessarily be a commercial tower. It would really be a memorial tower, which would be both a statement about rising high again and have a symbolism, but also be a kind of, become an incredible place.
It's important to go forward, to redevelop the World Trade Center, perhaps not as 210-story towers, because I no longer think that that is pragmatic. I think that people might be concerned, would be concerned about working 70, 80, 90, 100 floors up. But what I think is reasonable and rational are towers of 50, 55, 60, 65 stories in height, maybe even 70 stories in height.
Marilyn Taylor is chair of Skidmore, Owings & Merrill, the architectural firm commissioned by Larry Silverstein.
Should there be a very tall building? Wouldn't it be wonderful if we could reach into the skyline again? We all miss the Twin Towers in the skyline. Not that they should be replicated, but perhaps something should be there. Sculpture, light, I mean, all of these things will be a part of seeking the symbolic quality and the meaning that the site had before, but in doing it in a new and even deeper way.
Regardless of their design or height, lessons have been learned, and what happened at the World Trade Center will change the way buildings are constructed.
First of all, we need to look at fireproofing. Definitely in this case, fireproofing was not protecting steel, and eventually it collapsed because of fire effect. What we have to do is we have to design buildings such that they put up a fight with the planes trying to get in. When plane hits something, if you have enough resistance, the stresses in the plane will be high enough to fracture the plane itself and hopefully drop the wings outside. See, the wings hold the fuel. If you are able to keep the wings outside the building, then you've done it. You are not going to have intense fire inside.
We shouldn't be designing buildings to withstand airplanes hitting them. We should be keeping airplanes away from buildings. We all know how to build bunkers. We have to build them occasionally. Fortunately, not very often. They are not the kind of buildings that people want to occupy.
I think we'll always have skyscrapers. They are efficient in urban environments. Skyscrapers of 4 million square feet each are not necessarily required, but the typical skyscraper of 1 million to 2 million square feet that might be 50 to 60 stories, I think we're still going to have these kind of buildings. I think the real issue is designing a building that re-establishes the comfort of the public to be in that building. And the issue is that in that building, you can save the lives of people if there is a terrorist attack. And you do that by trying to make the structure stay up as long as possible and trying to make sure you have adequate egress for the people as fast as possible.
Robert Frost said, in 3 words, I can sum up everything in life that I've learned about life. It goes on. And so it will at the World Trade Center, the scene of so much pain, destruction, sadness, effort, and courage.